Hey guys, this is Dr. Mans, and in this screencast, I want to talk to you about the anatomy of an atom. So, what is it that makes up an atom? And more specifically, what are all those subatomic particles that are involved?
So here are a bunch of ants just hanging out on a tree branch here. But these ants are pretty awesome because you can see this stuff right here. Seems to be flying away from them. This is acid. Yeah, this is some formic acid. So these guys over time have evolved this pretty awesome defense mechanism by, if they don't want you around anymore, what are they going to do? They're going to shoot acid out of their abdomens. So that's pretty sweet. So how do they do that? Well, it's chemistry, simply put. And the ability of them to do this depends on the elements and the atoms that are in their abdomens. And the fact that some of their body is composed of an exoskeleton and some of their body has acid inside of it all depends on what is present. So there are elements, and those elements are composed of atoms. So let's talk a little bit more about these atoms, because really the fact that this is an exoskeleton and this stuff right here is acid all depends on the properties of those individual atoms. Okay, so now let's talk about how we would go about building an atom. So the first thing you need to have an atom is a nucleus. A nucleus is composed of two things. You've got what are called protons and what are called neutrons. Protons have a positive charge. Neutrons don't have any charge. They're neutral. So there's one very easy way to know how many protons and how many neutrons you have within an atom. Why would that matter? Well, because every single element has its own distinct number of protons. That's what actually decides which element you have on your hands. So for instance, if we have helium right here, it would appear on a periodic table that it would look sort of like this. Okay, it would actually be He for helium. So there's a couple numbers on here. This number is what's called the atomic number. And this number is what's actually going to tell you which atom you have, because which element you have, because each element is going to have a different number of protons. So this number, the atomic number, is equal to the number of protons that are in the nucleus. That's all it is. So that guy right there. The atomic mass is this thing. So this is basically how much this thing weighs. It's 4.003 daltons, which is really tiny and means basically nothing to you in terms of actual weight. But this is how we show the mass of one atom of helium. So this is basically how much does it weigh. Or the mass. Okay. Now, of course, weight and mass are a little bit different depending on gravity, but just keep in mind the actual definition is the mass of that atom. So the mass of the atom depends basically on the nucleus. So how many protons there are and how many neutrons there are. So that means if you want to know the question, how many neutrons are there in this atom? How do you figure that out? Very simple. You go to the total weight, which is 4.003, or basically 4, and you subtract out the number of protons. So 4 minus 2 is 2. So there are 2 neutrons in this nucleus. Why is that? That's because the total mass, how much this thing weighs, is protons plus the neutrons. So you should be able to take any element on the periodic table And if I tell you, hey, the atomic mass, which is basically the weight of the nucleus, okay? Weight of nucleus equals 6. So we'll say 6. And I tell you the atomic number equals 3. The atomic number, remember, is the number of protons. So the mass, or sorry, the number of neutrons in this thing is going to be 6 minus 3 equals 3. Okay, so let's look at it actually, looking at an atom. So this is the nucleus of an atom. And it's got some positively charged stuff in pink. Those are the protons. It's got some neutral stuff in brown. Those are the neutrons. So if you count these up, you're going to see there's 2 protons and there's 2 neutrons. So, okay, what is the atomic number? The atomic number is equal to the number of protons. So atomic number equals 2. And so then I would say, okay, how about tell me the atomic weight, atomic mass. The mass is basically how much stuff is in the nucleus. So that equals neutrons, 2 of those, plus the number of protons, there's 2 of those. So the atomic mass is 4. So that should sound familiar. If you look at helium on the periodic table, you'll see helium, it'll have a 2 up here, and it'll have a 4 point something, something, something. So this is basically what helium looks like if you were to draw out the nucleus. So the next type of particle we need to talk about is electrons. So if this is the nucleus right here, there will always be electrons that are circling that nucleus, and electrons have a negative charge. Since protons have a positive charge, these two things are going to be attracted to each other. So the protons, neutrons, and the electrons, these guys, are what are called subatomic particles. They're called subatomic particles because they're part of an atom, but they're not, they're just parts of the atom. So they're like subunits. So they're subatomic particles. And the number of electrons that you're going to find circling this nucleus in a neutral atom is going to be equal to the number of protons. So protons number equals electron number. And electron I'm going to abbreviate with this E with a minus sign. So if we were to draw on another proton right here, then we would also need to draw another electron out here. And if we drew another proton in here in the nucleus, we would need to draw another electron out here around that nucleus. And we also would need to add another neutron because the number of protons and neutrons are also usually equal to each other. So that's how it works when you talk about building atoms. Now the next topic I want to introduce to you is called electron orbitals. Electron orbitals are basically where are the electrons in relation to the nucleus. So where are they all hanging out? So in the simplest explanation or diagram, orbitals can be like planets or planets circling a sun. Okay, so you can have an orbital that's close to the nucleus and another orbital that's a little bit further away, like this, and even another one that's kind of way out here. Now, what you should actually appreciate is that the orbitals are really more like clouds. Okay, so if this is the nucleus here, the electrons are existing in this cloud, in this hazy area, just kind of zipping around out here. They aren't going in a nice pattern like this. They're actually flying around, zooming around this kind of cloud, and each cloud is kind of an orbital. So you have a cloud here, and this whole cloud counts as an orbital. And the further away you get from this nucleus, the more energy these electrons are going to hold. And we'll talk about this in class. But what you should know is the vocabulary word valence electron. A valence electron is one that is basically the farthest from the nucleus. Or in other words, it's in the outermost shell. Okay, so it's time to review now. So, first of all, I said neutrons and protons are what form the nucleus, the atomic nucleus. There's a bunch of electrons that are going to basically be in a cloud around that nucleus. The mass of protons and neutrons are basically identical, and we measure them in something called Daltons. And Daltons are really tiny units of mass, but that's what we use to measure them. Different atoms are going to have a different number of subatomic particles. So basically the number of protons in helium are going to be different than the number of protons in sodium. We'll get into this in class. The atomic number, this is a word you all need to know. Atomic number is the number of protons. Atomic mass, or the mass number, is the sum of the protons plus neutrons. So how much does the nucleus weigh? So this is what you should think of. How much does nucleus weigh? And if you're looking at the periodic table, you're going to see the atomic number here, the mass number here, and the name of the element here. And the number of electrons are going to match the number of protons in a neutral atom.
So that's all for now. I hope you guys found that helpful, and I will see you next time.